Let's solve Unit 5 System Software and Operating System questions. Which of the following control problem does not exist when processes unaware of each other during interaction? Processes unaware of each other will be called as independent processes because they are not intended to work together. A process is independent if it does not share data with any other processes executing in the system. A process is called cooperating if it can affect or be affected by the other processes executing in the system. Let's see a word about the options and then conclude which is the answer. What is mutual exclusion? If process P is executing in its critical section, then no other processes can be executing in their critical sections. Starvation means a situation in which processes will be waiting indefinitely. What is deadlock? It is a situation where two or more processes are waiting indefinitely for an event that can be caused only by one of the waiting processes. When you take independent process, they can be executing the critical section without minding others. That will definitely do a problem in mutual exclusion. If process P1 is not going to be aware of P2 which is waiting for the critical section, P1 is taking a long time and ultimately P2 will get into starvation because it is a situation where the process is going to wait indefinitely. What about deadlock? If there is going to be some resource R for which two of the processes are waiting and another process is already using that, until that process which is holding the resource gets another resource, it is not going to leave this resource. So these three problems will occur when the processes are not aware of each other during interaction. From this we can rule out 1, 3 and 4. What about data coherence? Data is same everywhere. When there is no need to share any data, data coherence will never be a problem for independent processes. Option number 2, data coherence will be the right answer. Next question. In Windows scheduling, which of the following option is correct? Windows schedules threads using a priority-based preemptive scheduling algorithm. The Windows scheduler ensures that highest priority thread will always run. Priorities are divided into two classes. One class is called non-real-time priorities, which you are seeing in the options, and another one is real-time priorities. What are non-real-time priorities? The variable class contains threads having priorities from 1 to 15. They can be adjusted dynamically. Real-time class contains threads with priorities ranging from 16 to 31, and these are assigned statically. There is also a thread running at priority 0 that is used for memory management. So the priorities are actually in the range of 0 to 31. 32 priority values are there. In that 0 is for memory management, 1 to 15 is for non-real time, and 16 to 31 is for real time. The base priorities for each priority class are real-time priority class, high priority class, above normal priority class, normal priority class, below normal priority class, and idle priority class. Here they have tabulated some values. This is actually real time because the complete column is having values between 16 to 31. The rest of the table is having values in between 1 to 15. You cannot find 0 or anything above 15 here. The range is completely between 1 to 15. Here they are asking which of the following option is correct. Since all the options have non-real time priorities here, any value between 1 and 15 can be right. If the question was which of the option is not correct, I would have marked option 4 as the right answer because 16 belongs to real time. If you total up the total non-priorities, count is also 15 here. But in real time you have exactly 16. So you cannot mark option 4 anywhere. So in this case, if they have asked about the highest priority thread, we could have given 15 as the answer. Maybe when you take 4, 8 and 12, 12 would have been the highest option, so we would have gone there. In my opinion, non-real time priorities have acceptable values of 4, 8 and 12, all three can be correct. If they ask you what is real time, then definitely option 4 will be the right answer for real time priorities. Next question, the sequence of steps for a page replacement algorithm will be. In the reference book of operating system, you could have seen a paragraph. Page replacement takes the following approach. If no frame is free, we find one that is not currently being used and we free it. We can free a frame by writing its contents to swap space and changing the page table and all other tables to indicate that the page is no longer in memory. We can now use the freed frame to hold the page for which the process faulted. Now just check the options. Find a frame that is not currently being used. This is actually option A. Change the page table. This is option B. Use the freed frame. This is option C. No frame is free. D is here. Free a frame. Free it is actually free a frame. So here we will have E. Now get the order from here. No frame is free will come first. Then we have to find one that is not being correctly used and then free the respective frame. From there we are going to change table and then use the freed frame. D, A, E, B, C. Option number 1 will be the right answer. Next question, which of the following is not correct about the virtual memory segmentation? Virtual memory comes into place with a large address space where we feel the physical memory is not enough for the tasks. What is internal fragmentation? It is the unused memory that is internal to a partition. Say for example, if you have a space called 100 and you are going to use the partition only for 90, the remaining 10 is going to be unused memory within this partition. This is internal fragmentation. Segmentation can prevent internal fragmentation because segments can be of different sizes. Only when you have some fixed size, you will get into that problem. Segmentation is actually used to prevent these kind of issues. The question is about virtual memory segmentation. It has no internal fragmentation, so 2 is a right statement. It helps in executing bigger processes with less RAM. It increases the degree of multiprogramming. Degree of multiprogramming means you can go with more number of programs or more number of processes. In that case, this point is actually contradicting the 4th statement. Let's check the other statements. It is not necessary to load all the segments of a process. Whenever it is needed, it can be loaded. Until then, it need not be loaded. So 1 is right. Regarding 3, it has large virtual address space. Yes, it is true. When we feel the main memory is not enough, we go for the virtual memory concept. So this point is also true. Increase in degree of multiprogramming statement is contradicting the term lower degree of multiprogramming. So we go with option 4 as the right answer. Next question, match list 1 with list 2. Let's take the RAID levels here. RAID 0, 1, 2, 3, 4, 5 and 6 are given. So let's match level 2 now. It is memory style error correcting code. We will map A to 2 error correcting code. A2 is available in 2 of the options. We will rule out the other 2. What is RAID level 3? It is bit interleaved parity. B is mapping to 4. We can rule out even 4th option. What is RAID level 4? Block interleaved parity. This will be matching to option 1. C1 is given. How do we match the remaining level 6 to Reed-Solomon codes? So here they have talked about P plus Q redundancy in the reference book. Let's see the statement. RAID level 6 stores extra redundant information to guard against multiple disk failures. Instead of parity, here error correcting codes such as the Reed-Solomon codes are used. This is where we can map level 6 to Reed-Solomon codes. D will be mapping to 3. Option number 2 will be the right answer. Next question, match list 1 with list 2. Thread spawn, block thread, jacketing and flush. What is the term called spawn? Spawn means we can say it's to produce or generate. So it is about the creation of thread, we can say. When a thread is created, it is provided with its own register context. Threads are created in the following way. So we can map A to 4. A4 is here and it's here. We will rule out 1 and 4. Block thread. Processor turn to the execution of another ready thread. So when there is a thread and when we want to pause the execution and move to another thread for another work, that is called as block thread, where the processor will be turning to the execution of another ready thread. It means I am just leaving this thread and moving to another thread. B is mapping to 3. B3, B3. Let's see about flush. It is the process of emptying a file, buffer or memory area of its contents. So it has nothing to do with blocking call to unblocking call. So we can map jacketing to 1. C1 and not 2. So we can even remove 2. Based on the meaning of flushing process, I am marking C as 1. So what is jacketing? It's to convert a blocking system call into a non-blocking call. What about flush then? D will be mapping to 2. It is to reclaim pages. So D will be mapping to 2 here. Option number 3 will be the right answer. Next question, match list 1 with list 2. Let's see the details about the list 1 options. In multiprogram batch systems, jobs with similar needs are batched together and run as a group. The objective is to maximize the processor use. A will be mapping to 3. What about time sharing systems? Processor's time is shared among multiple users simultaneously. Many people will be accessing the processor at the same time. The objective is to minimize response time. Time sharing will be mapping to 4, minimize response time. A3 and B4 is available in option number 2. The rest of the options can be cancelled. When you are running jobs in batch systems, all the jobs will be grouped together and the processor will be utilized to the maximum. For every job, you are not taking the processor little by little, but you are using the processor in an efficient way to the maximum by running it in group. That is why we are mapping maximizing processor use to batch programming. In time sharing system, nobody needs to wait for the other. All the users are going to access the processor at the same time. If everybody is going to access the processor, nobody needs to wait for a long time, which says that we are minimizing the response time. Monitor is a collection of procedures, variables and data structures that are all grouped together in a module or package. The monitor construct ensures that only one process at a time is active within the monitor. This says that the user no longer has direct access to the processor because it is going to ensure that only one process at a time is active within the monitor. So we can mark monitor to user no longer has direct access to the processor. Re-entrant procedures means a running procedure has to expect that second call will be made while a previous call has not yet completed. Re-entrant code never changes during execution. 2 or more processes can execute the same code at the same time. So when 2 or more processes are going to execute the same code at the same time, it allows more efficient use of the main memory. D will be mapping to 1. Option number 2 has C2 and D1. From this we can mark option number 2 as the right answer. To know about batch multiprogramming and time sharing, you have to look into the topic types of operating systems. To know about monitors, look into the chapter process synchronization. You can check this even in the reference book. Regarding re-entrant procedures, you have statements about it in process chapter as well as in threads chapter. Next question. Which of the following is not the characteristics of a specialized embedded OS? What is an embedded operating system? It's a specialized operating system designed to perform a specific task for a device. The device will not be a computer. The operating system will be designed in such a way that for whatever purpose you have built that device, for that purpose only this operating system will work. An OS will be present, but that OS will be restricted to the functions of that device alone. That is embedded OS, where they say the concerned OS is designed to perform a specific task for that device alone. Embedded systems almost always run real-time operating systems. You have two kinds of interrupts in this OS. External interrupts come from input-output devices. Internal interrupts arise from the illegal use of an instruction. Internal interrupts are commonly used in embedded systems such as microcontrollers to handle internal events such as timer overflows without the need for external events. Now let's see the features or the characteristics of specialized embedded OS. It's fast and lightweight process because you are not going to give the complete package of OS here. Whatever is needed for the device, that alone is going to be given. Scheduler policy with real time because they have told it runs real time operating systems. Since we use real time operating systems, we go with real time scheduling policy. It is small in size. It responds to interrupt quickly. It minimizes interrupt. It provides fixed and variable sized memory partition. It provides special purpose files. It provides bounded execution time. And it provides special alarms and timeouts. Now let's check the options. Real-time scheduling policy is here. So we have this characteristic. Response to external interrupts. So they say it responds to interrupt quickly. We can take this to be statement 2. It provides special non-sequential files. It is actually special purpose files. You cannot say they are non-sequential and all. This term is not there. So we can mark the second one also. What about the fourth one? It provides fixed or variable sized partitions. Yes, it is available here. So third statement is alone missing in this list. We can mark option number 3 as the right answer. This option is not a characteristic of specialized embedded OS. Next question. The order of steps of address translation in Linux virtual memory scheme will be. So let's see the address translation process. A virtual address needs to be translated to the physical address. This is what we call as address translation. Here this is the diagram that is taken from the OS reference book. This is not with respect to Linux, but it is the general operating system they have given. So here is a register. Here is the page directory pointer table, and from here we have a page directory. Then we have a page table, then we have the concerned page and the offset. The address will include page directory, page table, the concerned page and the offset together. This is how the format will be. Now let's see the same diagram with respect to Linux virtual memory. This CR3 is a notation of this particular register. So we can mark this as register. From there we have something called page global directory. Then we have page upper directory, then page middle directory, then we have the page table. From the page table we go for the page. The linear address is made up of 5 parts here. Global directory, upper directory, middle directory, the table and the offset. Based on this diagram, we are going to mark the answer. We have to go for the order of steps of address translation. The first part is the register. So we go with A. We can take page directory to be page global directory or page upper directory. So here this is page directory and this is page table. In between you have something called page middle directory. So this page middle directory is option E, and this together we can consider as page directory as given here. So C is here. Then page table is there. We go for D. After the page table they have given offset. This is B. So this is middle directory E, the table is D and offset is B. So this together can be taken as C. We have the order here as C, E, D, B starting with the register A. A, C, E, D, B. Option number 2 will be the right answer. Now let's see a word about all these terms. When a process switch occurs, Linux saves the CR3 control register in the descriptor of the process previously in execution and then loads CR3 with the value stored in the descriptor of the process to be executed next. It will store the value in the previous process descriptor and then loads the same register with the value stored in the next process descriptor. So previously there is a process here, there is CR3 and this is next process. So this will save the content and then move to the next one. So when you move, you have to automatically load it. So this is why we see load here and we see save here. When the new process resumes its execution on the CPU, the paging unit refers to the correct set of page tables. So the paging model has so many directories. We'll see them. The page global directory includes the address of several upper directories, which in turn include the addresses of several page middle directories, which in turn include the address of several page tables. So global directory has many upper directories and each upper directories will have many middle directories and each middle directory will have many page tables. Each page table entry points to a page frame. Thus, the linear address can be split into up to 5 parts. So, this is the overall idea about all the terms used in the Linux paging model. Even if you are not sure about this Linux scheme, keeping this in mind, you can mark page directory first, page table next, offset next, and in between the directory and the table you can place a middle directory, option E, and you have to start with the register, option A. Even with this diagram you will be able to answer this question. With this we are completing Unit 5 solutions.